welcome back to the channel. I want to ask you something. How does a compass know where north is? Even where you are in the middle of nowhere. How can a magnet pull a piece of iron without touching it? Is this not amazing? And here is something even more mysterious. Did you know that the earth itself is a giant magnet? All right. Today we are stepping into another invisible world. In our previous lesson, we explore electric forces. And if you haven't watched that video, please go back and watch that interesting video so that it will help you understand magnetic forces and field. And we are moving from electricity to magnetism. And I assure you that by the end of today's lesson, you will understand how magnets work, how magnetic field surround us, and how the entire earth helps you find directions. So get your book, pen or pencils, and let's begin. All right. So in our last lesson, we discovered electric charges create electric forces. And we also established the fact that electric forces create electric fields. Now here is something more powerful. Moving electric charges can create what we call magnetism. And that connection, electricity and magnetism, are connected. And this very connection powers the motors that we use, the generators that we use, and even our mobile phones that we use. But first, we must understand what magnet is. So what then is a magnet? We are saying that a magnet is an object that produces a magnetic field and can attract certain materials. Not every materials, certain materials. Notice something very important. Magnets do not attract everything. They only attract specific materials. And the materials that magnets strongly attract are iron, nickel, and cobalt. Remember, not all metals are magnetic. For example, gold, aluminium, copper, they are not magnetic. That is why we are stressing on the fact that not all metals are magnetic, meaning not all metals get attracted to magnet. Only certain metals respond strongly to magnetic forces or attraction. That is a key scientist fact you need to put at the back of your mind. All right. So let's move on to look at what magnetic poles are. We know that every magnet has two ends. And these two ends are what we call the poles. And these poles, we have the North Pole and we have the South Pole, as you can see on the screen. We have the North Pole and we have the South Pole. Okay. Now listen carefully. This is extremely important. Now in a magnetic poles, they always comes in pair, no matter how it is. Even if you break a magnet in the middle, it always comes in pair. We still have the North and the South poles. You cannot have a North Pole alone without the South Pole. Even if you cut it in half, as I said earlier, you still have the North and the South Pole. And each piece becomes a new magnet with its own North and South poles. That is powerful, right? And that is exactly how magnets are. They have two special poles or ends. And these ends are what we call the poles. And we have the North and we have the South Pole. All right. What happens to these poles when they are connected? Like we see in electricity, that like poles repel and unlike poles attract, so it is in magnets as well. This is the rule you have to keep in mind, that in magnets, like poles repel, meaning we have the north and the south poles. So it means that north and north, they are like poles, so they repel. South and south, they are like poles, so they repel. So if you see the diagram here, you will understand that this is a magnet with a south and north pole. And this is also another magnet with north and south pole. And we turn the north pole to the the north pole. So the north and north pole facing each other. In this sense, they are like poles, so they repel. They repel. But here, we see the opposite poles here. We have the north and south pole. This is a full magnet. And then this is also another full magnet. But here, we turn the south and then what? The north to each other. So these are opposite poles. And what it does is that they attract. They what? Attract. All right. So that is what? How the magnet works. That is how the magnet works. All right. So we move on. So we are saying that for north and north, they repel. But for south and north, they attract. Same in electricity as well. So now what is a magnetic force? A magnetic force is the interaction between magnets and magnetic materials. The interaction, the relationship between a magnet and a magnetic materials. Definitely there will be some objects or materials that get attracted to the magnet and some that get pushed away by the magnet. And this is what makes it fascinating. Magnets do not need to touch like electricity. They act from a distance. That means magnetic force is a non-contact force. It does not need to get closer before you see its effect. Just like electric force. Just like gravity, how it works. They are invisible but very real. That's exactly what happens when it comes to what? A magnetic force. All right. So let's look at magnetic field. As we have seen in electric field, we have magnetic field as well. Now we are going deeper. Around every magnet, there is an invisible region. Okay? Around every magnet, as you can see in this diagram. Around every magnet, look at the magnet. This is it. But there is an invisible region that surrounds it. Look at it here, as you can see in this drawing. Here. Okay. This region is what we call the magnetic field. And the magnetic field is the area around what? A magnet, where magnetic force can be what? Felt. So this is where you can experience the force of this magnet. If another magnet enters that region, it will feel a push or a pull, depending on the side that it shows towards. So if a north shows towards the north, it will pull away. But if a north gets closer or towards the south, it will attract. This is what we are talking about. So if any different magnet is brought closer, they feel that force around or close to the magnet within the region, even without touching it. Though you cannot see the magnetic field, but you can see their effects. And in science, as we established earlier, if something has measurable effect, it is real. If you can feel the effect or the influence of something, such as a magnet or electric force, it means it is real. All right, we'll move on. So how do we then draw a magnetic field lines? So scientists represent magnetic field using a field lines. And this line shows what? The direction and strength of the magnet. And the magnetic field lines, they leave the North Pole and enter the South Pole. So when you are drawing, you draw from where? The North Pole to this direction, and then you move towards what? You move towards the what? The South Pole. They move in, and then they come here. And outside the bar, they move from north to south. So outside the bar, they move from where? North to south. As you can see here, they move from north to south. So this is how what? A magnetic field, the lines move. From north, from the poles, they move from north and then to where? To the south or into the south. This is how it works. So how do we know? Because that is where the magnetic field lines are closest together. So at the poles, they are very stronger. So when it comes to the poles, the North Pole and the South Poles, the forces are very high and strong. But when it comes to the side, the forces are not as high as compared to where the poles or the two ends. So when the line is spread, as you can see from here down here, these places, you realize that the forces here will be weaker. The lines here, as it's spread down here, it will be weaker. Within this region will be weaker as compared to where the pole side, as you can see here. So this is what exactly happens at the poles. And remember that the closer the lines, the stronger the fields. And the way the lines spread out, the weaker the field. This is what happens in a magnetic field lines. I hope it is clear. All right, let's continue to look at magnetic field strength. As we have established earlier, we know that as the lines are spread out, the forces becomes what? Weaker. So as you can see, at this region, the forces, the magnetic force is weak. It's at its weakest field. But when it comes to the poles here, this is where the strongest force is felt. All right, we move on to look at Earth's magnetic what? Field. Now, this is something amazing, and I want you to get closer and hear it better. That the Earth itself acts like a giant magnet. Is this not amazing? The Earth is a giant magnet. Yes, the entire planet Earth. It has a magnetic North Pole and a magnetic South Pole. And this is why compasses work. Even our Google map, this is what makes it work. So how does this compass work? You know, a compass contains a small magnetic needle, okay? A compass, it has a small magnetic needle. And that needle aligns itself with Earth's magnetic field, even though it is invisible. But the compass automatically points towards north without a touch. It is invisible and it works as such. Even though you cannot see the field, that is how exactly it works. That invisible force guides the ships, the airplanes, and even the explorers. As I said earlier, even the Google map relies on this to work. So magnetism is everywhere. The entire Earth is a giant magnet with a north and a south pole. And this is what this compass used to what? To operate and navigate every direction in the air, on the sea, and everywhere, even in our transport. All right. So brethren, learners, This is an interesting lesson. Seeing these wonders God has blessed us with, it is for us to tap in these blessings by having the knowledge on these items or objects, how wonderful they are, even without realizing them. So let's look at a quick review with some questions. You pause the video, answer these questions, and come back to confirm if your answers are correct. All right, what are the two poles of a magnet? Of course, I know you will say north and south. It has a north pole and a south pole. And the second question is, what happens when two north poles come together? You might have said they repel or they push away, and that is correct. And the final and third question is, where is a magnetic field the strongest? Yes, you are right. At the poles, the north and the south poles. This is where magnetic fields are much stronger. All right, if you get all correct, you are thinking like a physicist, and you have done well. So let's take a quick review or summary of what we have learned so far. We've established the fact that a magnet produces what? A magnetic field. And we also says magnets get attracted to certain materials like iron, nickel, and cobalt. And we says that every magnet has two poles. That's the north and the south pole. And we established the fact that this rule, you shouldn't forget, that like poles repel and unlike poles what? Attract. Meaning positive and positive, they push away, but positive and negative, they get attracted. We also learned that magnetic forces is a non-contact force. You need not to get in touch before we can see or feel its force or influence. And we also say that the field is much stronger at the poles. So at the north and the south poles, that is where the field or the forces of a magnet is high. And we also established that the amazing, fascinating earth that God has blessed us with in itself is a giant magnet that helps us find direction. They are invisible, but they are powerful. Learners, now here is something exciting. In the next lesson, we are going to connect electricity and magnetism together. You will discover how electromagnets work, how motors spin, and how generators produce electricity. This is where science becomes engineering. So, if you are serious about mastering physics, I will encourage you to subscribe to the channel, turn on the notification bell, and stay steady, because science is not difficult. It is logical, it is powerful, and now you understand the invisible forces of magnetism. See you in the next video. God bless. Bye-bye.